Okay, here are equation notes for when I'm gone on December 9th. We're going through equations, I don't know, for the 73rd time. We will go through them until we get them done. First and foremost, here are the things that I think are important for you. Right here. Some tricky things. HCO2, when it is a product, will not stay as H2CO3. It will turn into CO2. This should be CO2 and water. I'm going to change that right now. CO2 and water. This is what happens in Coke. When you open a Coke bottle, the CO2 leaves and you're left with flat water. All right, if you see something that says ammonia solution, it's NH4OH. Ammonia solution does not stay like that. If you produce ammonia solution, guess what happens to it? It becomes NH3 and then water. Oops. Water. MgCO3 always decomposes into magnesium oxide and CO2, and hydrogen peroxide decomposes into H2O and O2. I think if I were you, the first thing that I would do is, when faced with a word problem, is determine the type of reaction that you encounter, and then you should know some basic rules for each one of these reactions. First of all, there's a metathesis, which is fancy talk for double replacement, single replacement combustion, where if a hydrocarbon is combusted, the products are always CO2 and water. Anytime you see combustion, you know that there has to be oxygen present. Acid-base neutralization is a specific type of double replacement. An addition or synthesis reaction is two things coming together to make one. So the clue for you is there is one product. Now don't be fooled. It does not have to be two elements making one compound. It could be two compounds coming together to form one product. Decomposition is the opposite of an addition or a synthesis. It's something coming apart. The clue that you have one of those involved is there's only one reactant. The reaction of an anhydride, I bet you didn't even know what an anhydride is. We'll find that out later. A redox reaction that you should be pretty well versed in, and a complex ion formation. I attached the pen cast that hopefully works on complex ion formations to the website under equations. It's on the links on the main page. All right, on the AP exam, you should remember that all reactions go. You don't have to worry about finding a reactivity chart. AP wants to see you predict the products, so everything goes. Now, everything must be written in net ionic form. I think I've said this a million times as well. If you do not put it in net ionic form, then you're going to get no points. And it's really sad for you if you go ahead and do all that work and get absolutely nothing out of it. You have to remember what it is that is ionized. Strong acids are ionized. A strong acid is, the memory hook is no sober class clowns in Hawaii. So nitric acid, sulfuric acid, hydrobromic acid, hydrochloric acid, perchloric acid, HClO4, and hydroiodic acid are all strong. They break down into a proton and the anion. Remember, sometimes the anion is a polyatomic ion. A strong base is any base that is made from a group 1 cation. Soluble salts are also completely ionized. Anything that is not one of those three things is not ionized. Here's a really quick let's go over solubility rules. Anything from group 1 and the ammonium polyatomic ion are soluble. All nitrates are soluble. All acetates are soluble. Chlorides, with the exception of HAP, mercury, silver, and lead, are soluble. Okay, and then you see the non-soluble lists. Okay, you're going to have to be able to determine oxidation numbers really quickly. Remember, the oxidation number of an element is 0. Where this trips you up the most is in a redox reaction, they'll say 10 and you'll try to put a charge on it. Don't do that. Do recall that all the diatomic molecules, Hofbrinkel, hydrogen, oxygen, bromine, nitrogen, chlorine, iodine, I don't know where I am there, but you know what they are. They are bonded to each other, so you would always write Cl2, but it does have an oxidation number of 0. In a compound, the oxidation number of hydrogen is +1, except in a metal hydride where it is -1. Oxygen is -2, except in peroxides where it's -1. All the alkali metals are +2. All the alkali earth metals are, all the alkali metals are +1. All the alkali earth are +2. And the oxidation number of the halogens are -1. Remember, the sum of all oxidation numbers in a molecule or ion is equal to the charge. If it does not have a charge, that means it's a neutral compound. Okay, here is a double replacement reaction. You have 2 reactant compounds and they produce 2 products. Look for acid bases and salts. Okay, A is a neutralization. Now, if you have a neutralization reaction as in B, where this is the fancy way of writing acetic acid, a weak acid and a strong base, you will form this. The net ionic for the weak acid is you leave it alone. It does not ionize. Here, the HCl would have ionized. I don't know why I don't have the net ionic here, but here you go. Okay. All right. Oops. Let's pretend that is subscripted. All right. Well, that didn't work. All right. Oh, there it is. 2. Jeez. I'm trying to watch the LSU game while I'm doing this. It's not working out really well. Anyway. Okay. A single replacement. One element reacts, tries to bump out another element in the compound. All right, so you have to match. You have to have cations bumping out cations, anions bumping out anions. Please look at these examples. Here is a trickster in action. Ammonium chloride plus sodium hydroxide. So you would end up with the NH4OH, that's the ammonia solution, and NaCl. Okay. Now the NH4OH will not last as a product that way. It will decompose into NH3 gas and H2O. So the net ionic equation for this will be right there. This is the same trickster in action with sodium carbonate and hydrochloric acid. Okay, let's talk about a combustion reaction. Oxygen is always a reactant. If you have a hydrocarbon, remember that they're not going to tell you that it's a combustion reaction. They're going to say is burned, reacted in air, or something like that. It always produces carbon dioxide and water. Now, you can have a metal sulfide plus oxygen makes the oxide and SO2 gas. Okay, acid-base neutralization is the subset of a metathesis reaction. Remember, only ionize strong acids and strong bases. Here is another example of a weak acid and a weak base. This is the other way to write acetic acid. Okay, Peanut wants in this room. I'm not going to let her in. Maybe I will later. When you start getting bored, we'll have a little Peanut alert. Okay, a synthesis reaction, two or more elements or substances combine to form one product. Lithium metal is burned in nitrogen gas. Okay, remember they're telling you this time what is the thing that is burning in is nitrogen gas. There's no oxygen in this one. Decomposition is something falling apart. Here's your trickster. MgCO3 will become magnesium oxide and CO2. Here's the anhydride. Anhydride means without water. So if water, an anhydride is, you take a CO2 plus water and you form this. So this is called an acidic anhydride. You've gotten rid of the water and you've made an acid. So this is the way you could make acids, a non-metallic oxide plus water. Metallic oxide plus water makes a base. And if they're asking an ionic hydride would be NaH. And remember that the oxidation number of the H in this case is -1. Redox reaction. Remember, you have to balance for charge as well as for atoms. Now, at some point or another, you're going to have to figure this out. By far, you are going to have to know these two. The permanganate ion in an acid solution, if this is the reactant, it will form a product that has a manganese with a +2 charge. If it's manganese dioxide in an acidic solution, it will form manganese +2 as a product. The one that you already saw in your Thanksgiving reaction set was the dichromate. Goes from a +6 to a +3. These are not quite as prevalent, but you may see them sometimes. All right. Now the complex ions, I would like you to watch the pencast as soon as you watch this. I have given you a assignment to be done after these notes, and I would like you then to trade and grade it, and then I have given you homework to do, and we will complete it on Monday, and there will be a quiz on Tuesday.